Let's begin with noise audio amplifier ST2205. The noise audio amplifier ST2205 is an essential tool for understanding how audio amplification system handle unwanted noise. Noise can significantly impact audio quality, and learning how to manage it is a crucial in fields like audio engineering, broadcasting, and telecommunication. The trainer demonstrates how an audio signal is amplified and how added noise affects the clarity of the signal. Additionally, it allows us to explore method for filtering noise, improving the signal to noise ratio, which is key for producing clear, high fidelity audio. Understanding this concept is foundational for designing systems that deliver quality sound despite external or system noise. Begin with the experiment first. The objective of this experiment is we have to examine the operation of noise generator. The apparatus we are required is power supply, oscilloscope, and the trainer. Let's begin. We have connected the power supply to the trainer, 12 volt with the 12 volt, minus 12 volt with the minus 12 volt, and ground with the trainer's ground. Now keep the level of potentiometer in the channel and noise block fully anti-clockwise and the attenuation potentiometer fully clockwise position, like this. Fully clockwise, fully anti-clockwise, and fully clockwise. This block will be in the fully anti-clockwise and this block fully clockwise. After that, we have to switch on the power of the power supply, and then we have to connect the oscilloscope to the output socket of the channel noise block. Let me do it. Now we are ready. Let's switch on the oscilloscope. Now gently vary the level knob and observe that the amplitude of the noise goes increasing, like this. When we increase the knob, level of the knob, amplitude of the noise goes on increasing. So let's begin with our second experiment. We have to examine the operation of signal attenuation network. For this experiment, we are required one function generator. We had to set that function generator to peak voltage of 1 volt, amplitude and frequency ranging between some kilohertz and 1.5 megahertz. So we have to apply 1 volt amplitude to set it in sine wave. Let's do it. Now we have to change the frequency to 1.5 megahertz. It's done. After that, we have to give input from the generator to the trainer. Let's do it. And connect the ground from the ground. So as I told you earlier in the experiment number 1, we have to keep the level of potentiometer both in the channel and noise block in fully anti-clockwise direction and the attenuation potentiometer fully clockwise pose. Now let's connect the output of the trainer to oscilloscope. And to the ground. Now we switch on the power supply to notice the graph. As you can see that we are able to generate the graph. Now we have to just vary the knob of channel attenuation to see the changes in the graph. You can see the changing in the graph. Now increase the level of the noise. The graph is varying with the previous one. So you can see that when we increase the level of the noise, the amplitude will be decreases. When we decrease the level of the noise, the amplitude will increase. Now we are going to start with experiment number 3. In this experiment we have to measure the power output. First we have to connect the power supply to the trainer and keep the load speaker switch in the audio amplifier block at load position. As you can see here, it is in the load position. Now we have to increase the knob to the fully clockwise, like this. Now we are going to apply sine wave signal of 50 millivolt and frequency of 1 kilohertz in the function generator, and the output of this function generator is connected to the trainer inputs here. As you can see here, the input is connected and the ground is also connected. So the trainer's output will go to the oscilloscope, in the oscilloscope, to generate graph. Apply. You can see the graph. Now we have to increase the input signal amplitude until the output presents no distortion. Let's select the amplitude button. We can increase it like this. You can see the graph is changing little bit. Now we have to increase the input signal amplitude until the output presents no distortion. As you can see in the graph, the distortion is there, so we are going to increase the amplitude. You will see the graph is changing. It's done. Let's move to another experiment. For this experiment, our objective is to analyze the distortion with the square wave. We have to connect a function generator with a square wave of 50 millivolt amplitude, apply the signal to the input of the amplifier and display the output on the oscilloscope. We have to vary the frequency of the signal from 20 Hz and observe the effective amplifier frequency response of square waves. So we have to vary the frequency . To see the changes in the square wave. When we increase the frequency, we will be able to generate different kinds of square waves such as ideal amplifier, phase lead, phase lag. Right now we are having phase lag. Keep on increasing the frequency to generate different types of square waves. So after that, you will have a question that how will we generate the square wave. You just have to press the function button on the function generator and set to the SQR, that represent the square wave. Let's continue with the next experiment. This will be the last experiment on this device. Objective of this experiment is measurement of noise figure. As usual, we have to connect the power supply first, and this time we have to connect 100 kilohertz of sine wave of 50 millivolt to input of channel and noise block, this block, and then we have to set the attenuation level now fully counterclockwise. This now we have to, this is already in fully clockwise. Then you have to feed the output of channel and noise block into audio amplifier block. The output of function generator will come into the input of channel attenuation block, and the output of channel attenuation block will goes to the audio amplifier input, and that an audio amplifier output will go into oscilloscope for generating the graph. Here on the load speaker switch in load position and the volume knob fully clockwise. This should be in load position and volume should be fully clockwise. Now switch on the power supply to see the graph. We are able to see the graph. Now we have to measure and note the input and output voltage of audio amplifier block on oscilloscope. That we have to increase the noise level slowly while observing the input of the audio amplifier block, and increase the noise level such that the input signal is not fully distorted. After doing this, measure the amplitude of this wave. You have to increase the noise level. You can see the graph. After increasing the noise level fully, the graph is looking distorted. Leave the noise level potentiometer as it is and observe the output of the audio amplifier block. Take the difference between the voltage with noise and voltage without noise at the both input terminal and output terminal. Now calculate the SNR and also calculate the noise figure. I will attach the formula in the end of this video. This was the last experiment on noise audio amplifier trainer ST2205. So that is from my side. Thank you for watching this video.